Hello everybody, I am back with another video. This video is dedicated to those students who are learning for the first time. It is seen in most of the cases where students really struggle to understand vectors. So there are going to be a series of videos upcoming next, which will have some information that are vital to understand the physics of vectors. So let us begin to understand what vectors are in the first place. Vectors are essentially mathematical objects. So you can just see here that vectors are simply mathematical objects which can be used to represent physical quantities. There are so many physical quantities which are vectors. For example, force is a vector, displacement is a vector, velocity is a vector, acceleration is a vector. There are innumerable of them if I start to list them out. But you need to understand that vectors are not objects, they're not like numbers for you to add them up just like 2 plus 3 is 5. You cannot add them like that. There is a certain way you need to employ in order to add them up, because vectors not only have magnitude, they also have a direction. What I mean by that is, let's try and understand. Let's say that you have a vector. So this is a vector. Let me make this look a little bigger for you. So here is a vector, and the arrowhead gives you the direction of the vector, and the length of the vector gives you the magnitude. So this is a graphical understanding of whole of vectors. Sir, what do you mean by a graphical understanding? We will employ basic objects of your geometry box in order to get the answers for addition of two vectors, subtraction of two vectors, and so on. So here is a vector that you can draw on a graph paper. Let us say you can just write that you are talking about a force. So if you are talking about a force, you write F. F would in this case indicate a force. If you put an arrow on its head, it means it becomes a vector. Vector F is how you read it. Now, vector F is basically, let's say, 5 units, right? If you say that 5 units long, then you will have to draw this to some scale. Let's say about 1 unit is 5 centimeter. So if you are representing a vector that's 5 units long, then you will have to draw a vector that's 25 centimeter long, because 1 unit is 5 centimeter. 5 units would be 25 centimeter long. So because you're talking about force, you can just say that this is being measured in Newton. So the SI unit of the force is Newton, and you can simply say that this is a 5 Newton force. So the length of the vector indicates the magnitude, and arrowhead indicates its direction. You can say that this is east and that's north, this is in the northwest direction. So this vector has two parts. Any vector for that matter will have two parts. Number one, magnitude, which is indicated by the length of the vector, and the direction, which is indicated by the arrowhead. Now that's how you represent a vector graphically. Having understood that, it's time we now go and understand how do you add two vectors. There is a law that talks about how to add vectors. Let's find out. Come. We have the triangle law of vector addition. So let's try and understand what is triangle law of vector addition. Let's say you've got two vectors. Let us name them vectors A and vector B. So here you go. Let's say that you have a vector. That is a vector you have. Let us name this vector A, and you have another vector, let's say B. Let me just use this vector and just change its direction, maybe something like this. So you have another vector, let's say this is vector B. We'll write the name of the vector a little later. Now that's vector B. Now how do you add these two vectors? How do you add these two vectors? It's quite simple. To add both of these vectors, to find the sum of the two vectors, you call the sum of two vectors a resultant. That's what you call the sum of two vectors. So let's write down, what's the resultant? We want to find the resultant of vectors A and B. So if you add vector A and B, what is it that you get is the next question you have to answer. Graphically, you have to arrange the two vectors in such a way that you take them in the same order, just like this. So this is vector B. So you have vector B. This is vector A and this is vector B. And A plus B is what you have to do, and you have to find the result. And now let's look at the law. When two vectors are taken as two adjacent sides of a triangle in an order, that means you need to start drawing vector B when vector A ends, and that is in one order. The resultant is completely represented by the closing side of the triangle. So this is the closing side of the triangle, and it must be taken in the opposite order. Meaning, let's draw a vector. If I draw from here to here, it would be the same order. Look at this. Let's say if I just draw a vector from here to here, you say that this vector is in the same order. Let's draw this out like this. So A, B, and if you call this resultant vector, this is in the same order. But then the law says you must take the resultant in such a way that it must be in the opposite order. So how do you make it opposite order? Very simple. Let's try to figure this out. You will have to just do that. Now this is opposite order. And we're almost there. Yes. So that's opposite order. So you have A and then you have B. R is the resultant of these two vectors, right? R is the resultant of these two vectors. Maybe that. Okay. All right. Fantastic. So this is the resultant of the two vectors, and you can say R is equal to A plus B. Graphically, A and B, now this is vector A taken first, B taken next, and the resultant is A plus B. Do you see that R is smaller than this length plus this length? So if this were 5 and if this were 10, the answer is not 15, because 5 plus 10 would have been 15, but here it's not 15, it's less than that. This is a triangle. That's a property of a triangle. Having said that, now the next question you should ask me is, sir, is this particular vector addition commutative? Let's find out. What if you were to compute A instead of A plus B, you were to write B plus A? What is it that you would get? Let's find out. So for doing B plus A, you will have to draw B first, right? Let's draw B here. Okay. And let me write vector B here. Now that's vector B. And let's write vector A next. Let me just move this vector here. Just move this vector here. And then you have vector A, which has been moved here. Do you see? Invariably, the resultant is simply the same. Before it was A plus B, now it is B plus A, but the answer remains the same. Neither the magnitude nor the direction has changed. So you simply get the same resultant. So vector addition is absolutely commutative. A plus B is always equal to B plus A. So this is a basic understanding using triangle law of vector addition. Let's go further and compute this with the help of a little bit of algebra and trigonometry that we know. So the same law of triangles is now extended and it becomes parallelogram law of vector addition. Let's try to figure out what is parallelogram law of vector addition. It says when two vectors are taken as two adjacent sides of a parallelogram taken from a point, then the resultant is completely represented by the diagonal of the parallelogram taken from the same point, the law says. Let's try and understand this with a diagram. So let us say that you've got two vectors. So this is vector number 1, right? And you have, let's say, vector number 2, something like this, right? let's say this is a little smaller, that's vector number 2, right? We will name these vectors. Let's call this vector A and let's call that vector B. The angle between the two vectors, let's say, is theta. Theta is the angle between the two vectors. Now the question is how to draw resultant in this case. It is just triangle law of vector addition. You just want to see that? Watch. Let me copy and paste B such that I form a triangle. So B has come here, the same vector B I've copied and pasted. Let me copy and paste A as well. Let me copy and paste A as well. So I've copied A, I've pasted A. Now, when that is the case, this is vector A. Do you see, you get a parallelogram, and that's how the parallelogram law of vector addition starts off. If you just see this is A and B, that's A and B, by the way, and they are taken in the same order, A and B. The resultant is completely represented by the closing side of the triangle. Now this is a triangle, you see. It's completely represented by the closing side of the triangle taken in the opposite order. That's what the triangle law said. Now you copied and pasted A and copied and pasted B, you get exactly the same thing, but now it looks like a parallelogram, so it has now become parallelogram law of vector addition. So you have the triangle here. If you just, let's say, delete this and this, you have the triangle law A plus B giving you the resultant R. So essentially that's how you get resultant R. But then let's say you have both the other vectors which are copied and pasted, you get a parallelogram. So that's just the difference between parallel law and parallelogram law of vector addition. If you realize, then they are just one and the same. Having said that, you can still write that vector A, when added with vector B, you would get the resultant R. All said and done, vector is about two things: the magnitude and the direction. Magnitude is a length and direction is an angle, let's say. Because when I say I have given you vector A and vector B, which means I have given you A and B both in magnitude as well as in direction. And that is the case. You have vector A and vector B. If you want to calculate length of this vector, that will become the magnitude of the resultant. And if you can calculate either alpha or beta, you have specified the direction of the resultant either with respect to A or with respect to B. And if you have done that, that means you've shared with me the direction of the resultant as well, which completes the description of the resultant vector. Having understood this, let's find the magnitude and direction of resultant R. Let's try to figure this out. In order to do so, let me make a small construction. I would like to extend this vector A further like that and drop a perpendicular from vector B, right? Something of that sort. All right, that's good. Okay, something like this. It's great. I've just completed it, extending this, and I've dropped a perpendicular there. Now, because this whole angle is theta, this whole angle is also going to be theta, right? We want to find the length of R, which means the magnitude of R. It's quite simple to see that this is a right angle triangle. You can just call this O, P, and Q if you like, and maybe this is, let's say, S. O, P, Q, and S, right? So these are 4 points that I've marked. It's a right angle triangle. It's right angled at Q. It's right angled at Q. You can certainly write Pythagoras theorem. So instead of writing vector R, if you want to specify the length of the vector, just the magnitude of the vector, then you would simply write magnitude of vector r. You put it in between these two lines, you're telling me that you're only talking about the length of the vector, not the direction. So magnitude of vector r, which is the hypotenuse square, is equal to this length square, OS and OQ, the total length. But from heights and distances, you know that, my dear friends, that this length is the adjacent side of this triangle PQS. So adjacent side, because you know the hypotenuse, it's magnitude of B. The hypotenuse in this case is magnitude of B. You can write magnitude of B cos theta, and this can be written as magnitude of B sine theta, because it's the adjacent side. Just from the knowledge of heights and distances, you don't really have to bother too much about what that is. So the magnitude of vector r can be written as the sum of squares of the adjacent sides. Let's write this Pythagoras theorem first. So we have magnitude of B sine theta the whole square plus this whole length, because we are talking about the whole triangle. We're talking about the right angle triangle whose hypotenuse is magnitude of vector r, plus we have magnitude of vector A, plus you have magnitude of vector B cos theta the whole square. If you expand this, you will have r square, vector r square, equal to magnitude of vector B square sine square theta plus magnitude of vector A square plus magnitude of vector B square cos square theta plus 2 times magnitude of vector A into magnitude of vector B into cos of the angle between them. So it's like A plus B the whole square. It's A square plus B square plus 2AB cos theta plus 2AB. That's what the cos theta is just there here. Anyway, if you can look at these two terms, term number 1 and term number 2, you can pull out B square as a common factor. If you did that, then you will have R, magnitude of R the whole square, being equal to magnitude of vector A square plus magnitude of vector B square can be pulled out as a common factor. Inside the brackets, all you will have is sine square theta plus cos square theta, which you know is going to sum up to 1. And here you have 2 times magnitude of vector A times magnitude of vector B times cos of the angle between them. If that is 1, then you have an angle, if you have the answer for the resultant squared, which is equal to magnitude of vector A squared plus magnitude of vector B squared plus 2 times magnitude of vector A into magnitude of vector B times cos of the angle between them. This is the equation for resultant, magnitude of the resultant of the two vectors. All right, everything said and done. Let's try and understand how to calculate the angle, because I told you that if you can tell me what the angle is, you have certainly solved the problem in its complete. It would be the complete description of the resultant. The problem would be complete. Then let's try to figure out how to calculate that angle alpha. You can just write what's tan alpha. Tan alpha would simply be equal to, look at this triangle, it's OPQ. Opposite divided by adjacent. Opposite is magnitude of B sine theta divided by the whole thing, which is magnitude of vector A plus, okay, it looks like this line became too slant. Let me write that again. I have vector B, magnitude of vector B sine theta, whole thing divided by magnitude of vector A plus magnitude of vector B cos theta. So it's opposite divided by adjacent. That's how I got that. Of course, alpha would be tan inverse of B sine theta divided by A plus B cos theta. That's how you would write that. So if you were to write what is beta, beta would be tan inverse of A, magnitude of vector A, sine theta divided by magnitude of vector B plus vector A, magnitude of vector A, cos theta. That's how you would write beta. A similar thing can be done with beta as well. Now, students usually suffer from this confusion. Sir, how do I know whether to associate B or A when I'm writing alpha or beta? How do I get to that? So, the trick to remember it is sine and cos stick to that vector to which the angle does not stick to. Let's try and understand that. Sine and cos are sticking to A. Do you see sine and cos are sticking to vector A? But beta, which is the angle you have written here, it does not stick to A, it sticks to B. So sine and cos will come with A, and what comes along here would be the vector to which beta sticks to. The same case is the case with alpha. It's a trick to remember the formula. Alpha is tan inverse of vector B sine theta divided by A plus B cos theta. Sine and cos stick to that vector. See, sine and cos stick to that vector. They should be sticking to B because alpha sticks to A. Look at alpha, it sticks to A. So that's how you remember it. I'll be coming up with a lot of problems based on these exercises. These are for you to understand. Watch the video and then jot down these things. Try and understand these things conceptually, and then we will try to apply it once these concepts sit in your head firmly. With having this understanding, let us go further and look at some important points. Vectors add like numbers if they are in the same direction. Now, why would they add like numbers if they are in the same direction? See, let's say we have vector A and then we have vector B. Both of them are in the same direction, so the angle between them would be 0. Theta is 0. So the resultant vector R, I wouldn't write magnitude, I wouldn't write magnitude of resultant R. From now on, I'll simply write R. If I simply write R, it means that I'm referring to the magnitude of that vector. So R is equal to root of A square. Of course, I've just taken the root on both sides. A square plus B square plus 2 times AB cos theta. This is the equation. When that is the case, if you put theta equal to 0, when you put theta equal to 0, cos theta becomes 1. So R becomes equal to root of A square plus B square plus 2 times AB is all you will be remaining with. If that is the case, then this is simply the formula, which is A plus B the whole square. That makes it A plus B. See, the magnitudes add up like vectors. But if they are in opposite directions, let's say that this is vector A and this is vector B, then the magnitudes of the two vectors would get subtracted. So in this case, the resultant would be equal to magnitude of A plus magnitude of B. Let's say this is 10 and this is 5. The resultant will be 15. The resultant will be 15. This is only going to happen if A and B are on the same direction. If they are not, then you must resort to using this formula. The angle between A and B becomes absolutely important. Having said that, let's continue and talk about this particular case. Seemingly A is longer than B. If that is the case, the resultant vector will be only this much, because B is this long and you will have to take off that much from A. What is remaining will become resultant vector. It's like 10 minus 3 or maybe 10 minus 7. You have 10 in that direction, 10 in this direction. They get subtracted. 3 will remain in that direction. That's all. So that's how you compute vectors when they are in opposite direction. Of course, cos 180 degree is what you would get here. Cos 180 is minus 1. You will get A minus B the whole square formula, and that's why in this case the resultant would simply be A minus B in magnitude. Having said that, let's go further. The resultant of vectors always inclines more towards the longer vector. What I mean by that is, let's say that you have a vector here, it's a longer vector, and then you have another vector which is a shorter vector. Well, the resultant vector will always look like this. The resultant vector will always be this way. Do you see that the resultant vector inclines more towards the longer vector? So you can just say that this is vector A and this is vector B, and that's the resultant vector R. So let's say that this is A, this is B, and this is R. Because B is longer, the resultant vector inclines more towards B. From now, it's a good practice. If I ask you what's alpha, how would you answer that? That's something that I want you to think about. It's quite easy. You have tan inverse of, you first write sine theta divided by cos theta. That's what you would do, theta being the angle between A and B. Sine and cos would stick to that vector to which alpha does not stick to. Alpha sticks to B. So you will write A and A here, and then there will be a B here. Now that's how you would find alpha, just as a matter of revision. But anyway, that's quite obvious. The resultant of two vectors which are equal in magnitude and is always in the direction of angle bisector. What I mean by that is, let's look at this. I have a vector here, and this vector, let's say, is called A, and I'd like to take a similar vector which is equal in magnitude. Here it is, and let me change the direction of that vector and place it here. The resultant of these two vectors is going to be along the angle bisector. You can verify that using the same formula, because A and B are exactly the same, and then you will find that it's going to be theta by 2. The angle is going to be theta by 2. That's a homework for you. Please realize that if A and B are equal in magnitude, show that alpha is going to be theta by 2. That's the question I leave you with. But anyway, so theta being the angle between the two vectors here, alpha, my dear friends, if these two are equal, then it's going to be theta divided by 2. I said you have to verify that, and then if you are able to do that, then please comment this in the comments. Please comment a thumb on the comments. But anyway, with this basic understanding of vectors, I'd like everybody to go through this particular video and try to take examples and learn vectors and get a basic idea of vectors, so that next time when we use these vectors in complex concept, you will be able to handle these mathematical objects with ease. But do remember, the day you stop growing is the day you start decaying. Thank you.